And we should be live.
Great. Okay. Um, hey everybody, I know it's been a while, but um I think we might just start with like a little recap of some of the work that I did on my own when I streamed like a week or two ago. And then we'll talk a little bit about the proof of concept like client protocol thing that I've been working on, and we can sort of discuss the trade-offs, pros and cons, whether or not it even makes sense. Um, so let's start with maybe what I was working on the last time I streamed, which was refactoring the entity manager to try to track a lot more of the life cycle of the entity manager in a scope versus doing it all manually. So this refactored entity manager um, still pulls in a lot of like information, but instead of using a synchronized ref for for managing the entities or the collection of entities, I'm instead just using a plain ref, and I've created a semaphore within the entity manager that I can then use to more granularly control when things get locked and when things don't. Because uh, I was finding that like using the synchronized ref was making it more confusing in certain scenarios, like because of how because we want to be like very granular about when we're locking and when we're not. It just actually ended up being more explicit to use the semaphore directly. Um, so we can talk about that. And then so that was one of the big changes I made in this version. And then another one of the big changes that I made was, like I said, tracking a lot of information inside a scope. So this manager scope here is the scope that's associated with the entity manager. And then the individual entities themselves also get a scope that's forked off the manager scope. So that this way, if you like shut down or terminate an entity manager, all of the associated entities will also be cleaned up as well, since their scope is forked off the manager scope. Um, so let's maybe look a little bit at what that means. And I can show Mike kind of like some of the stuff. Also, excuse me if I have to mute myself occasionally. I have a cough. Um, so we can probably start maybe with this like getter create state method, which is the method that receives an entity address and sort of does the work of spinning up the actual entity or the resources that an entity needs, and then starts running the behavior associated with an entity. So the whole thing is wrapped in a semaphore, just like it was before with synchronized ref, but just ended up making more sense to wrap it. I mean, again, we're using a semaphore directly here instead of a synchronized ref. So I refactored a bunch of this again to make use of both the manager scope and the entity scope. So there's a couple of things that have to happen when we're actually bootstrapping an entity. The first thing that we do is we check if the sharding service for that pod is shutting down. And if sharding is shutting down, then we like immediately fail, because if sharding is shutting down, we can't spin up a new entity on that pod because the sharding service is shutting down. But if sharding is still active, then we can go ahead and fork a new scope off of the entity manager scope for the entity's resources. And we bind that to this scope variable. And then we can look at this expiration fiber thing in a second. But we create a queue of mailbox storage entries. So these kind of represent the mailbox of the entity. And We could use the new mailbox module to do this, but to keep things a little bit simple, I just started with a queue. And basically, like, the idea here is we create a queue. The mailbox storage entries are essentially what we get back from mailbox storage, when we actually create a message. And, like, when we add a message to mailbox storage, yeah, the entry is what we get back. Um, and so we spin up a queue, a mailbox for the entity itself, and then we add a finalizer to the new scope that we created, this entity scope, um, to basically shut down the mailbox. So um, if the entity's scope gets closed, the mailbox will get shut down. Any like fibers that are all the takers for this mailbox will also get interrupted. Um, and then we start the behavior here. And this is a little, like, I guess not tricky, but like a little weird. So I'll kind of explain what's going on. So we start the behavior itself. You can ignore the replier thing for a second because we'll talk about that in a minute. Um, and then if the behavior ever exits, so it's a never-ending effect, but if it's interrupted or anything like that, then we want to make sure that we close the scope that is associated with that behavior, because that means that the caller is shutting down that entity. So in the effect.ensuring block here, we close this entity scope that we've spun up. And then we also fork the behavior inside that same scope. So we basically,
And apologies, just a quick question. In this way, we're also providing the scope to the behavior, or are we just forking inside the scope?
at the moment, we're not technically providing the scope to the behavior, but we could. We could also give the
Okay.
behavior the ability to attach resources to that scope, so that if the behavior gets terminated, like, it has that scope available. Like, that's totally possible. I just haven't like implemented that here, but we could do that.
Yeah, I mean, probably it's like if we have a scope, I don't see why not to attach it. But yeah, later point.
We also have metric bookkeeping to perform. So again, we can use the scope to do this. I really think we should add decrement APIs to the metric thingy, because this just feels weird. But we start out by incrementing the gauge that's associated with the number of entities that we have of a given type. So again, just going up to the top of the entity manager here, this gauge is a gauge that tracks the number of entities of a given type. So when you spin up a cluster, one of the metrics you'll have access to that's associated with the cluster is the current number of entities of each type. So like if you think about it in like a Prometheus format, you might get like a list of entities and their type, or a list of metrics with the entity type and the count specified for that metric.
That's
Um,
nice.
yeah, it's like a nice, and we can add as many metrics as we want to this, but this just felt like I think Shardcake has this too, or they are adding it. I'm not sure. Um, and then the very last thing we want to do here is make sure that the first finalizer that we run within like when we're within the entity's scope is the actual removal of the entity from the collection of entities that are being managed by this entity manager. So like when we actually do the shutdown, when we close the scope, because of the order in which we're adding finalizers here, if we do this tap last, we can make sure that the first thing that happens when the scope is shut down is that we remove the entity from the entity's like map that this entity manager is tracking. This way, like, we immediately remove it from the map, and then we can do all the other shutdown behavior after the fact. But this like kind of very quick like removal thing is a good thing for us to have happen first. Um
Again, here to remind the listeners, the order of execution of finalizers is the reverse of the order in acquisition. So if you acquire the first one, acquire the second one, acquire the third one, and in shutdown, the third one will clean up before, the second later, and the first at the end. This is because there can be dependencies between resources acquired. And for example, if you acquire a database connection, then you acquire a transaction, you want the transaction to close before you release the connection.
And I got to give credit where credit's due. It was Tim's idea to use a scope to do all of this. I just took it and implemented it, but he was the one who was like, "Why don't you just use a scope?" And I was like, "That's a great idea."
Team is known for having good ideas.
He has good ideas. So, and then the very last step that we perform here, this last tap, is the state that we create. So where are we? Where do we get the state? This. The scope, and so the scope associated with an entity state, like the entity state object, is no more than the queue at the moment, is no more than the mailbox for that entity and the scope associated with that entity. So for each entity, like in this hash map, like the entity's hash map, all we really have is a mapping from an entity address to an entity state. And if we look at like the implementation of entity or the definition of entity state, like I said, it's just the entity's mailbox and its scope. So at the moment, where this is all we're tracking for every entity, but we can add additional fields in the future as they make sense. But I wanted to start simple with this new iteration of Entity Manager. So again, all of this happens within a semaphore, so we can make sure that all the updates we're making to this ref is atomic. And yeah, so that's the new kind of get or create state. I think it makes more sense to do it this way as well, because again, if we think about like what happens within sharding, when we deregister or if an entity manager ever needs to be shut down, like from the sharding side of things, all we need to do now is like close the scope associated with an entity manager, and then all of the associated entities also have everything that they need shut down. So it's kind of a nice like propagation here, where from a sharding perspective, we have this like set of entity managers, which all are tracking their individual entity types. And all we have to do to shut down all the entities associated with the manager is actually just close the scope of the manager, and then all of the entities get shut down. How would it work? Sorry, Mattia's asking a question. How would it work with entities shutting down but receiving messages? Wouldn't the state entry still? No, the first thing that happens is you're not lurking, Mattia. It's okay. So like I mentioned, the very first thing that happens when the scope associated with an entity is shut down or is closed is that the entity is removed from the entity's map. So it won't be able to receive messages, if that makes sense. I don't know if that answers your question, Mattia. Feel free to answer in chat if it does not.
By the way, if you want to hop into the stream, just message me on Discord and I'll send you the link.
Cool. So when we actually use get or create state, this is when we're actually like sending a message to an entity. So we get the address and the entry that we want to send. So again, the mailbox storage entry is just the information we're getting back from mailbox storage once sharding has like received that message, tried to put it into storage and gotten a response back. If it's a like, yes, we inserted the message response, then the entry is what we get back and what we forward to the entity. So this information is what we get. We do a get or create state for that address. And then we offer the entry to the entity's mailbox. And then we keep trying to do this every 100 milliseconds if it fails, because this could be a situation where maybe the entity like hasn't spun up or died for some reason and is going to be brought back up or something like that. Okay, so Mattia's asking another question. Even a long interruption phase would be handled, something like behavior doing weird. Well, again, Mattia, the very first finalizer that's run, the reason why I'm adding finalizers in this order, so even if like the behaviors interruption takes a long time, the very first finalizer that's run is the removal of the entity from the map of entities. So like that entity won't be able to receive messages anymore.
But it'll be able to do work.
Yeah, it'll still be doing work. It's shut down, like procedures, but it won't be able to like receive messages anymore. It'll still like have the ability, like if it's got a long interruption phase, like you mentioned, Mattia, like yeah, effect on uninterruptible, effect.sleep, blah blah blah. Um, that can still be happening, but the entity itself won't be like available to receive messages.
The small concern I have, and I'm not sure if it's handled already or not, is basically, let's say these entities shutting down for an interruption. That can happen, for example, if a node is leaving the cluster. Okay, when do we actually communicate that the entity is down, or maybe rather that the shard is down? Because my concern is if we allocate the entity in another, or rather, if we allocate the shard in a different pod and that entity is still running, we could have an entity which is running twice, which is not ideal. But I guess that depends on when the shard is flagged as deallocated. That probably waits for the whole shutdown of everything to before we communicate to the shard manager that the shard is deallocated.
I mean, it's something we'll have to think about. The other thing that could potentially be a problem here is that if we're still receiving messages like via send message to entity, um, getter create in the current implementation, getter create state is just gonna spin up another entity for this message. So one of the like this is a problem that I wanted to discuss and like potentially address here where like think about it. If we we are receiving messages, the entity's doing work, then all of a sudden we shut down that entity. The entity is immediately removed from the entity map, right? But it could still be doing work, as you mentioned. If we get another message coming in, it's going to hit this getter create state, and the uh the um whatchamacallit, the entity manager is going to basically just spin up another state for it because the only check we're doing here is like, is the address in the hash map? If not, then we have to like spin up the state. So one of the ideas that I had to manage this is instead of like the first thing that we do is to remove the entity from the address, we could change the way that entity state is defined. State where instead of entity state just being like a plain interface, we could have like a tagged union where like if the entity is active, this is the information you get. But the second we terminate an entity, the state just becomes like a terminated tag. So the entity would still be in the map, but all of the methods that handle like checking the map for the entity would see that the entity is terminated and basically like have to do, I don't know, if we could figure out what would happen at that point. And that's actually sort of kind of what Shardcake does here. And also is sort of kind of what we did in the previous implementation. It's like slightly different, but the idea being is that like we could still have a similar like setup here, but instead of like just removing the entity from the hash map, we could set it to like a terminating state. And then once like the everything is done here, like the first finalizer that we put in the finalizers array could be removing the entity from the map. But the last one that we enter in the array is just setting it to like terminated, right? So like we set the entity to terminating or whatever. It runs through all its shutdown behavior, right? So if the behavior takes a really long time to shut down, then the entity's still in the map, but it's terminating. And then the very first thing that we finalize or that we add to the scope is currently what we have is the last finalizer, basically. So that this way, like, once the behavior shuts down cleanly and finishes, and maybe it takes 10 minutes, maybe it takes 10 years, whatever. Once the behavior is finally done, and that finalizer is finished, then we can run the first one. And the key here is that we're running finalizer sequentially, not in parallel. So this works, right? If we were running finalizers in parallel, it wouldn't work. But like, that's another idea to manage the case where messages are coming in. Because right now we're not handling the case where like messages come in and the entity has been like essentially, um, you know, started its shutdown procedure. Because now the entity manager doesn't even know about it.
We could actually also use STM, and like in the get or create state, it's like you're gonna wait either for the entity not to be in the map, so you can create a new, being sure that there is no other entity, or you wait for an entity to be there, but not in a terminating state. So with STM you can do any check you want, and then just retry, and it'll wait for the precise condition to be met to avoid this kind of mixing up.
Yeah, I mean, I think any of those things are reasonable. I think like I have yet to use STM in a project, so if this would be kind of like a fun
Okay,
test.
might be the good time.
uh, but I also think the original implementation is reasonable as well. The other thing is the entity scope. STM seems nice. um,
Yes, it is nice.
STM is nice. I mean, we could try to sketch something out if you're interested, Mike. I would need a little bit of help since I haven't really used STM very much before. But if you want to try, we could try that. Otherwise, we could finish talking about like some of the
I
other
think we
ideas
can
that
do
I
it
had.
either offline at a different time, and eventually like recap it in the next stream. I
Okay,
don't think it's gonna be useful to like spend the stream studying STM. That could be another stream though.
that could be another stream.
It could.
Um, so and the send method that I originally had here, it hasn't changed. It's pretty much still the same thing. Let me move this to here. Basically, we get an encoded envelope that comes in through the send method. We decode the envelope. We attempt to try to save the message into mailbox storage. And then if we successfully save the message, we get a mailbox storage entry back. There's still a lot of problems with like the storage interface here. Yeah, I agree, Mattia, that it could be a good use case to learn the usage. There's still a lot of problems with like the storage interface that I need to address. But the idea here is that we get the envelope, we decode it. The first thing we try to do is save the envelope to the storage. And then if we successfully get an entry back, we send the message to an entity and it goes through all the pieces that I showed before. Otherwise, if we get a no such element exception, that's the case where the message has already been saved. Like there's already a message in mailbox storage, so we don't do anything. It's an effect up void. If we get a parse error from decoding the envelope, we create a new malformed message error, which is a custom like error that I created, which we can iterate on in the future. But at the moment, it basically just forwards the cause, which should render out the parse error with the tree formatter when you get a stack trace, I think. And similarly, we need to figure out, or I need to figure out what to do when we get a message persistence error. Whether or not that should be forwarded to this, like basically lifted to the send or whatever. And then in the previous implementation of send, I was using, I was providing a context, but now I've just changed this to provide the full runtime, because this way we forward fiber refs and runtime flags and all the nice stuff that's inside the runtime, which is kind of the goal. And the whole reason for those who haven't, like maybe haven't watched before or don't know, the reason we're doing this is to essentially lift the requirements for decoding the envelope to the construction of the entity manager, so that when the entity manager is actually running, like it has all the dependencies for that entity and it can just inject them like in during the send, because the um because schemas have the ability to use effect context, right? So the um the the idea here is that we want to be able to lift the context for the message up to the construction of the entity manager. This
Because
way,
basically, otherwise, every single send instruction would require the context.
yep. And also, we don't necessarily have, like, once the entity manager is constructed, we lose the type information for the message because it doesn't make sense to track at the type level. Send, like, we don't, we actually, I don't remember why, but I'm pretty sure this was like very difficult to do. So in this way, we can actually make the entity manager agnostic to the type of message it's going to get, but the construction of the entity manager knows about the message type. So this is why, like, we're able to essentially we lift the context and everything else about the message to the construction, and then the actual entity manager at that point doesn't really know anything about the type, or at least on the type level, it doesn't know anything. Um, okay, so let me just remind myself what else I wanted to talk about. Um, did I do anything with last active times? Last 15. Yeah, okay, so the next thing I wanted to talk about was the concept that I was thinking about for, because we had been saying in previous streams that we have thus far been ignoring like kind of the client interface. So like how do we actually send messages, or how do we actually respond to messages from a behavior, right? So your behavior gets a message or gets the mailbox for the entity and can pull messages out of the mailbox. But at the moment, we didn't have any way to actually like respond to that message. So I sort of thought about like this concept of a replier, which we can take a look at. So an entity replier is basically an object with a bunch of like helper methods on it, like succeed, fail, fail cause, complete. You can sort of kind of see the similarity here with request almost, um, where like um, if for anybody who's used the lower level request resolver um, methods in effect, you'd probably make use of some of these methods, right? If you're using like a request resolver, you need to basically say how you're responding to a request. So the idea here was to have something similar. And we can construct a replier on demand for a behavior and use that to proxy certain pieces of information back to the cluster based on what happened with that message. So if we go back to, oops. So the idea here, and it's, haven't been like, I haven't fully fleshed this out yet, but the idea here is similar to a request. The base method that a replier has is this like complete method, right? And the complete method receives the message as well as the like full result of that message, right? So um, both the success and failure case.
So from the behavior, we would call the replier interface to send the result.
Yeah, and actually, let me show you the interface of a kind of like, this is again what I was like sketching out. I thought it might be useful. Rotate windows. So this is again not fully fleshed out yet, but the idea for like a behavior, right, is you get a DQ of messages, which we could also change to like a read-only mailbox in the future if we wanted to do that, right? It could, if it makes sense. Like we have a mailbox module in effect now. Um, and then so you get basically access to two things. You get the mailbox for the entity, but you also get the replier in the signature of behavior. So then like within your behavior, which becomes just a function, right? You have the mailbox, replier, and you might do some like effectful stuff. And then you would basically, gen, yield replier dot complete message. Maybe we have like a, right, mailbox dot take, and then we do some stuff to process the message and get a result. And then the replier has different methods on it, but the idea is like if you have an exit, you could do just the exit directly. If you have a success, you could just do replier.succeed message and, value, whatever. So, but that's kind of like what I was thinking is like this replier could be the proxy back to the cluster, to allow us to take the result for a message and communicate all the information we need to get back to the cluster. But you have access to it in your behavior, if this makes sense. Um, so anyways, so to create a replier, you give it the address. And again, this is done for you, like when we actually spin up the behavior, so you just get access to the actual replier. Mattia is asking, so when you get the entry object, you get both the additional informations and the replier for that message. Well, it's not a replier for that message, right? Because you, the reply, like when the signature of a behavior takes in, or you get the mailbox and a replier, so that you can reply to messages. So based on like how you pull messages, like, because we wanted pulling messages to be controllable by the user, right? If you want to pull fast, then you can. If you want to pull slow, you can do that. But so you would be taking messages from the mailbox. I missed message before. Did I? I'm sorry. Yeah, the idea would be like this complete method is like the base method of like a replier, right? This is the most basic low level way that you can call a replier. Was suggesting an alternative.
Because I think at some point, Shardcake had a replier type, and you could send repliers as objects inside messages. Because you could even have like funnel things where you could have multiple recipients, and you could send like the addresses to through the message. This is a slightly different thing though.
Yeah, I know that Shardcake has a replier. I was taking a slightly different approach based on the goals that we had, which were like, one of which being, when we reply to a message, we want to also update stuff that happens in the database, right? We want to mark the message as processed. We want to mark the last time that an entity was active. We want to do a bunch of stuff like when a particular message was processed. So I took a slightly different approach. My replier is the only association between a message and a replier is through the actual like methods that the replier has on it, the replier wouldn't get sent through with like a message or anything like that. But I know Shardcake has that type of API. Um, um, but yeah, so this is like one idea I had, right? Where this is essentially injected into your behavior. And then because this is now inside the entity manager, we have access to all of the stuff in the entity manager's constructor's closure. So because Mike had said during one of our last streams that to track for the termination fiber, right? For the time to live for an entity, the last active time should be the last time an entity processed a message, not the last time an entity received a message. Because in Shardcake, it's the latter, not the former. To do that, we need a way to track the last time an entity processed a message, right? And I thought this was like a clean way to do that, right? If you complete a message, you can then immediately mark the last active time for that entity inside the replier.
And just to sort of repeat myself again from last time, the reason the TTL should be from the last processed message, and, well, not per se the last processed, but like if there are messages to be processed, of course the entity shouldn't shut down because there's work to do. So the condition assumes there's no non-processed messages. So the queue basically is empty. And the last processed messages was expiring more, it has an expiration time which is larger than the TTL. Otherwise, the risk that we incur is that an entity receives the message, takes a month to process because the business logic for that specific thing takes a month, and we end up shutting down the entity after 30 minutes. We
Right.
passivate the entity when it should still do work. Obviously, it's a very different use case from Shardcake because in our case we need to guarantee processing of things. We're not just sharding a cluster for the means of like computation. Here we want to run workflows and so on and so forth. So we need a bit more reliability.
Right. I think I need to, in my expiration fiber logic, I think I still need to add the check somewhere. I need to add the check somewhere in here for whether or not the mailbox is empty. I'm gonna have to figure out where that makes the most sense, because the mailbox is, I guess, when we actually terminate the entity, we're gonna have access to the state here, and so basically we can just skip. We can prevent terminating the entity, like because you said we
but
need.
then you would enter in a loop.
Yeah, we would need to figure out like a place to put that check that makes sense, but
By the way, what is the trigger? Like, do we have something like a cron tab that we check every sometime when the termination should occur?
Sort of. This expiration fiber is the thing that tracks uh when we should be actually terminating the entity. So essentially we have a fiber that sleeps for the max idle time. And then after the max idle time, it tries to
This is
terminate
per entity.
per entity, yes. Because if you look at the getter create state, one of the first things we do is we start this expiration fiber inside that entity's scope. So this fiber gets shut down if the entity ever gets terminated as well. But the idea here is you sleep, you get the current time and the last active time, you compute whether or not it's greater than what it should be, right? And if the amount of time that's remaining until like the time that we should expire is greater than 0, then we just keep sleeping. Otherwise, we return void, which allows the actual entity termination to occur. Um, so again, this logic could be improved. It's a little like contrived at the moment, but it works.
Well, I
Um,
mean, we could have one fiber per pod, basically, and that fiber kind of loops every, I don't know, every second or every 5 seconds, and it checks every entity for the condition, which is like, okay, an entity could be terminatable, or an entity can be passivated if the mailbox is empty and there are no incoming messages and the time expired. So like we need to track all the entity objects that we need to track anyway, probably. Because when we shut down the pod, we need to shut down all the entities, so the objects are tracked anyway. We could have a single fiber do the whole job instead of having two fibers, basically one fiber for a behavior and one fiber for the expiration. Even because I don't quite understand how the TTL resets. It's like if fork the fiber, it sleeps for max idle time. But if I receive a new message, if I get a new message, like if I process a new message, then the sleep should delay because it's a TTL from the last processed message.
so yeah, the one it grabs the last time that that particular entity was active from the map of like the last active times map. So last active times is just a map of entity address to number.
But
Uh,
maybe I'm not understanding. Do we refork a new fiber at every message we receive and kill the previous one?
no. Wait, sorry. Do we refork a new fiber on every message? No. We only fork a fiber when an entity is created. What we do is constantly update this last active times map based on the last time a message was processed. So we basically compute how much like the
Got it.
remaining
So
time.
when that fiber ends up it has slept enough, then it checks again. Did I have new messages or not? If so,
Precisely.
compute the difference and sleeps for the difference. Makes
Yeah.
sense.
Yeah, so it just suspends basically for the max idle time. And then once the max idle time is over, we check if we should terminate. And if we should, then we continue. Otherwise, we just suspend again. Um,
Makes sense.
so it's pretty like lightweight. But we are spinning up like a fiber per entity this way.
Yeah, I mean, that's probably fine.
And then what's really nice is so when we actually terminate an entity, like all we have to do is close its scope, which is pretty nice. Like the entity termination logic before was a little bit messy, but now we can just basically lock the manager, terminate the entity by closing the scope, and then continue. The only thing I'm not sure here is like because we're locking the entity term, like we're locking here. I don't know if this makes a lot of sense because that means the entity won't be able to create like this getter create state won't be able to do anything while we're terminating an entity. And if an entity takes a long time to terminate, that could be a problem. So that's like, another place where having like that like terminating state could be like useful for the purposes of like tracking termination and all of that sort of thing. Because like locking the manager during termination could be not great. What else? I think that was most of what I did in the entity manager last time, like when I was kind of just trying to figure out a way to do all of this. Um, one of the other things I ran into was, I think when I was trying to write, Yeah, I haven't like fleshed all of this out yet. But this is kind of like the idea I had for like basically what you would be specifying when you actually go to create a workflow. So, it's not working yet, but this is kind of like what I was going for. So, you specify the protocol, right? So we have a this for a counter entity. You get the count, you increment the counter, and you decrement the counter. All messages are required to have a primary key, because if they don't, there's no way for us to have a unique ID associated with them. Like we can't just like randomly compute that. So in the entity managers or in the entities make method, I'll show you like some of the shenanigans I had to do to
Okay.
get this work.
To clarify one thing, this is the message protocol of an entity. It's not necessarily a workflow though.
This is the message protocol, not necessarily a workflow. Sorry. This is the message protocol for an entity. And then defining a behavior. Like this is basically me trying to show like the API I'm going for a cluster entity behavior, like all of that kind of how it fits
Yeah,
together.
this basically defines an actor with the messages that the actor can receive and so on and so forth. Get
Yep. Yeah. So you define your messages. Every message is a tagged request. So for those familiar with tagged requests, we use them for a lot of things in effect. You define your success schema. So when the message is processed, this is what you should succeed with if the message processing was successful. If the message has the ability to fail, what's the schema, excuse me, for failure? And then what's the payload that that message is going to take with it into the like entity? So in the
Given that the primary key is required, we might want to have our own little extension of that request, which might even go in schema itself, uh, with something like persisted target request or something similar to actually force the user specify that, and actually not really to force the user to specify that, but rather to ensure the return type. I know this is probably ensured at cool site, so if you
it
screw
is,
up the type, you can't pass it in.
yeah, I mean, I have specified it at the call site, but it's not like great. Also, I had to do some shenanigans to get this to work. I'll show you what that
I
looks
can
like.
imagine.
Um, but
Last week I had a number of shenanigans that you can't even imagine.
yes, well, but when you actually like construct an entity, like this counter entity, like the entity itself basically tracks the protocol that you're going to be working with. Um, for behaviors, created this little like helper type, this like get behavior helper type, which allows you to easily create a behavior for like a particular entity. We could probably do this a different way, but
Can probably have a make behavior function.
right. The only thing with the make behavior function is you'd have to pass the entity in for virtually no reason, but that might just be nicer than like might be nicer than this. Probably
We're
nicer
not
than
really
this.
caring about tree shaking here, so
Right. Um so I mean you could also take it as a type parameter. Like you could easily do the exact same thing. But anyways, um the point here is that
or less trivial because you could have also stuff like context and so on and so forth. Which, by the way, you can even have here.
yes.
So
Um so like again, this is like not taking really anything else into account, but the point here is that you have your mailbox, you have your replier, um, and the idea here is that, you know, you basically are setting up an actor, like Mike said. So you have the ability to handle messages, so you can take messages from the mailbox, handle those messages, do it forever. Like you basically are setting up an actor here. But this is kind of like the API I was going for to some degree, where like
do we get an entity ID inside the behavior?
Oh,
And we had mailbox, replier.
I know what you're asking. Yes, we can add as many parameters as we want to the behavior. At the moment, it's just taking the mailbox and the replier, but we probably can add something like a meta data argument or something like that that gives you information about the entity that's like actually running this request. So you could have like meta.entity ID, meta.like shard ID. We can have all of that information propagated in.
Yeah, because I was thinking like now you're using just a subscription ref locally to store the state. But if we were to actually persist that state, you would need an identifier for the entity to like link state to the entity.
Right. And you can sort of see the again API I was going for the replier. So basically calling replier.succeed message count. It's essentially the same API surface as request in effect. So it's just doing more stuff under the hood for the like cluster specific stuff. Um so anyways, I didn't think this was too bad API wise. I thought this was pretty minimal. You're really only defining like what you care about. You're not doing any like gymnastics to get anything else to work. And the next thing I was starting to work on was like entity registration and what that would look like with sharding. And like, so the idea here is that, you know, you have your sharding service, you register an entity, and then you can get a messenger from the sharding service as well. So, sharding dot make messenger. Um, and this would take in the entity, and then you can use the messenger to do things. I mean, the mess.
Can you
Sure.
put that out of the dot effects so at least doesn't complain about the missing environment?
And the idea here is you'd get a messenger that can send these messages. So like messenger dot ask, and you can pass in the entity ID, and the message. So like maybe we have, you know, counter 1, new get count. Oops. And then the ID would be like, I don't know, something. And so with ask, you would be getting back, the return type here is not like correct yet. Not properly. The the messenger I've spent the least amount of time on, so like all the return types and everything are not right. But this is kind of like the idea that I had. So very similar to like current cluster, very similar to like current effect cluster, but just kind of doing things a little bit more uh in like an effect native kind of way, using tagged requests, using, you know, the ability to propagate context, all that stuff. So still like a lot of work to do, even just within the entity manager, but like I feel like this was a good the
It'll be so funny at some point because I do think it's very important for like the end goal of cluster is to really be the first clustering mechanism in JavaScript. So at some point we will also have to provide a non-effect API because like if mind blown, like the end goal of effect is to disappear. So we're gonna have to rethink everything for it to
that's
work in a non-effect way, but it's
that's
gonna
t-
be fantastic.
that's Tim's job. Tim can handle that.
Yeah, I think can handle that, yeah.
um anyways, yeah, I think like I mean I think that the current direction I'm going here makes is pretty decent. Like again, like pretty lean for like setting up an actor system kind of situation. Um so maybe I'll just quickly show like the shenanigans and entity.make. Um don't judge me for this, but uh so because I mean, this probably like makes perfect sense, but for some reason, when I got so deep into like a cluster, I just like lost sight of this. But because like when you're creating an entity, you're dealing with not instances of messages, but like the class itself, right? Like the actual like messages themselves. Envelope.anyMessage refers to the instance side. It doesn't refer to like the actual type. And so like in my mind, I was like, oh, I'll just use any message for the constructor. And that didn't work. So then I was trying to figure out how to make this work and also be safe on the type level. And anyways, Tim
And
kind of
schema
helped.
is invariant.
Yeah, so Tim kind of helped me with a little bit with this. It's a little dirty, but basically any message
That's the
schema.
same trick he used to make the API we were working last week
Yeah,
to work.
basically.
That's exactly the same trick.
Bas- Basically, any message schema is this, and it's essentially just refers to any message, which is this. And you can see that any
Thank
message,
God TypeScript is structural.
yeah, this is like a hot mess, but it works and it's type safe, amazingly enough. And so even though it looks a little dirty, it works. So yeah, that is how we did that. What else did I want to show you guys? Oh yeah, internally I just convert the schema to a union. Since we're getting on the make receives an array of messages, I just convert it to a union internally because when we actually go to decode,
And they're tagged anyway, so the union is gonna be a tagged union.
yeah. So like internally this is not a problem, but what else? What else? What else? I think that's really it. There's still like a ton of work to be done. I need to start getting back to this, but um, there's still some problems with mailbox storage that need to be addressed. Tim added support for MySQL to have multiple statements, so I no longer need to do two queries. I need to like write like a multi statement SQL query to send to MySQL to basically get back the information that I need. And there's still some problems with like the types in mailbox storage. For example, I think like when I go to insert a message, so when I go to insert a message, save message, yeah, ignore all the red. We get the entity address and the message coming in, but it's kind of weird because if you think about it from the entity manager side, right? The entity manager gets an encoded message, which we then decode in the entity manager to make sure that it's the appropriate message for the entity manager. We then save that message to entity's mailbox storage, where we have to reserialize the message. And then at the end, we deserialize it again. So there's like,
Do we actually need to?
well, I mean, we could return the message that came in, right? We
Yeah, the
could just,
original one here.
but that felt like it was getting towards the problem that we discussed many meetings ago, where we like talked about how we always want messages to go through the same process, right? We always want the CERD happening, which we do, right? Whether we're sending to a local entity or we're sending to a remote entity, the message goes through the same process. This felt like another one of those situations where we probably want to know when we get the stuff back from the database, like, is the entry that we're getting back from the database, does it match the message schema that we got, like, to save, basically, right?
Well,
I
I
mean,
mean, performance-wise, I don't think encoding and decoding a message a few times is gonna count in this case when you have network all over the place. So I think if we compare like the delays that you get when you send a message and get the reply and so on and so forth, I don't think encoding once or twice is gonna actually make any tangible difference. So I would agree. Let's start with encoding and decoding as much as it makes sense, and
Yeah.
we can always remove them. But
Yeah. The idea was
it's
to
very
basically,
important to detect issues.
that was kind of like the idea is like, we don't, when we come back from the database, like, okay, yeah, maybe we can be sure, but also like, are we really? And, we do to some degree already know that what we're getting back makes sense, right? Because when we're using effect SQL, which does the SERD for us as well. So it's just that the message body that comes back from the database is a string. So like, there's opportunity here to make this cleaner. But for now, I was just trying to get everything to like play nicely together. Um, but anyways, yeah. So what do you guys think about um, the entity manager, like the new entity manager, and also kind of like this like replier API to basically proxy information back to the cluster when we complete messages, etc. Oh,
I think it's,
one other
yeah.
thing. I'm sorry. One thing I did not mention at all yet is message acknowledgement, which we need for tell, right? And my idea for message acknowledgement, like when you tell a message to the cluster as opposed to asking, we need to be able to acknowledge.
Not from the entity though.
No, 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 no. I'm saying like the mailbox storage, once it
Once it's
receives.
persisted,
Yeah, yeah, yeah.
it's replying fine.
So we basically mark that message as processed in storage and we reply. So my idea was that, where is it? Somewhere, wherever we do the initial save of the message, I think it's in send. Send. Here. Um, here, we could figure out a way to respond to tells, if it makes sense. We just need to figure out a way to like do the response here if it's a tell versus an ask. Do you know what I mean? So still an unsolved problem, but this is where it would happen, right? We get an entry that comes in, and this is kind of like, this is the place where we're saving the message. So if we successfully save, then that would be the place to actually respond. We could do something inside like send message to entity, but again, we just need to know somehow that it's a tell versus an ask. So problems, still certain things are unsolved, but at least like I feel like we're moving in the right direction for like at least being able to reply to messages and whatnot. So but I still haven't solved like the tell piece. Anyways, now I'll let you comment. I apologize for interrupting again.
No, no worries. I think overall it's fine. Maybe at some point, like we could smooth further the API in the behavior and get like a single parameter instead of two or three and merge all of them. So like get a parameter which is the mailbox and the replier and the metadata. But that's just to like compact it a little bit more, not to have multiple arguments, but like those are refinements that at this point in time they're not important at all. So I like the idea of like separation to do the first iteration of work, so everything is more clear. And yeah, we've been discussing it even if you remember, maybe the very first stream that we did, that there is a very strong similarity between request completion and signaling of message completion. To a good extent, they are the same thing, and getting the two APIs as similar as possible. It's nice because it reduces the mental overhead. You could say, okay, when defining the behavior, if by any chance you already know of request resolvers, you have the same API. The concept is pretty much the same, with the difference that you have mailbox that you can pull messages from, but once you've pulled the message, you complete it in the same way. If you don't know that, then follow the example.
Right. So yeah, I think there's still a lot of like you said, polish and stuff, but I feel like the internals are starting to come together in a way that makes sense, at least a little bit. Um, it's hard, as Mattia probably knows very well, it's hard to fit all these pieces together,
Yes,
especially in a way that's reliable. But um,
that's why we're doing a rewrite.
right. So I think that there's still probably going to be like changes that need to be made to this, like for sure. But I think like at least we can probably proceed in this direction. And, also tests are going to pick up on problems. Like as we start testing pieces of the cluster, especially like in the entity manager, like where we're currently locking versus where we should be locking, the entity state, or entities state and all of that sort of thing. Like we're going to come across problems, but I'm going to
Yeah,
keep
but
moving in this
I also
direction.
think we should do a little string, not on cluster itself, but rather chatting a little bit about STM, going through some examples, going through how to use it. Because I think once you understand STM, many of those problems, if you model the state in STM, you just have transactionality. So a lot of things becomes easier. And
Yeah.
it could, like, performance-wise is slightly worse. For example, a semaphore. We are using an optimized version of the effect semaphore, which is as performant as humanly possible. That's fine. But a semaphore built on top of STM is 5 lines of code. And semantically, it works the same. Now, it's slightly less performant, but it works the same. And you can compose it with other transactional stuff. So you can like, okay, I want to lock this. Then inside, I want to do a transactional operation and so on and so forth. So the power is incredible. I think in those cases, just like paying a little bit of performance price to get absolute certainty over how the state transitions is very important here. Like this is the backbone of distributed systems. It should be the backbone of distributed systems. So we can't afford screw ups. Like, okay, the cluster is in a state where it did something that it wasn't supposed to do. That would be the worst. So I think like spending an hour wouldn't take more than an hour probably. It's a very simple API if you already know effect. And you obviously already know effect very well. So probably not even an hour, but we could like it's even fun to showcase that to the audience because it's a module that you wouldn't use in a normal case. It's probably for the 0.1% of use cases. But if you do have those use cases, it's just fantastic to use. And I think what we've discussed with this state alignment when locking, when not locking, and so on and so forth, it's like absolutely the perfect fit for STM. So maybe let's schedule another stream on STM, and then we see how to apply it, if to apply it to cluster next time.
Yeah, I think that makes sense. I mean, we can definitely get something. I think it would also be a great opportunity for folks to, like you said, sort of learn about a module that otherwise they probably would have skipped over. So
Good,
cool.
cool. This was fun,
Well, thank you everybody for
and
listening. Hopefully next time I have even more progress to share about cluster.
and you know, in 2 streams from now, we're gonna have the cluster up and running. Yeah.
That's right. That's right. We have a lot of time together coming up in San Francisco, Mike. So
Yes.
so but
There's even
anyways,
a team retreat where we have to hack on something. So
that's right.
yeah.
So
This by the end of November is production ready.
for Patrick, maybe. Well, anyways, thank you everybody for listening. Thank you guys for paying attention and asking questions. And yeah, hopefully we can get something together on STM quickly so that we can show that off and talk about that. So cool. Thanks, Mike.
Cool. Thank you very much. See you, folks.